Our project focuses on improving GE's wiring department through facility layout redesign. At the GE location in Charleroi, workers assemble high voltage circuit breakers. For our purposes, the area of interest is the 6,000 square foot wiring department. This is where the electrical cabinet is built. Our client, General Electric, has asked our team to improve and redesign the wiring department to increase their productivity and efficiency. There are several challenges we have identified and would like to address. The current production method causes a lack of consistent supply to cabinet assembly and excess work in progress, because panels are completed at irregular intervals. It is also important to address the layout of the wiring department as a whole. Currently, many of the workers have to make multiple trips per shift to go to the printer, bolt rack, tubing/insulation, and wire cutter. There are also several underutilized and inappropriately used spaces for work. To address the problems described above, we will convert the one-piece flow line from its current production method to an assembly-style setup, improve the overall layout of the wiring department, and address the problem of underutilized and inappropriately used spaces within the department. Finally, we will be constrained by the size of the cranes. It is critical that panel, mech, and relay wiring and cabinet assembly are positioned under the crane. Our first task was to find a way to convert the one-piece flow line from its current production method to an assembly line style setup. By changing the one-piece flow line to an assembly line style process, we found that it is possible to reduce the size of the staging area for completed panels. While the department size will not change, the congestion problem will be alleviated by eliminating some staging. Our second task was to figure out how to improve the physical layout of the areas within the wiring department. GE provided us with a CAD drawing of the existing layout, which we used to identify main areas within the department and their corresponding square footage. We used the detailed CAD drawing to create a block layout, which can be seen here. We created this block layout because we wanted to focus on the high level rather than the arrangement of the workstations themselves within the areas. In creating our recommended layout design, we first had to pinpoint the specific areas that had significant flow between them. We did this through examining process flow maps and time studies. We were able to determine an average number of trips made between each area per shift. We use these flow values along with their department areas to create an improved layout by using the spiral technique. From the spiral technique, we developed a block layout for our proposed future state as seen here. We also used the flow values to create an equivalent cost comparison. We were able to calculate the cost per shift of both the current and future layouts by multiplying travel distance by number of trips by cost per trip. We captured the travel distance by measuring the rectilinear distances between the centroids of each department. The number of trips were multiplied by 2 to represent the round trip. Cost per trip was determined by multiplying the time employees spend walking between departments by the average employee's hourly wage. The problem of underutilized and inappropriately used spaces is a widespread issue within the wiring department. To identify instances to address, we interviewed the workers and supervisors. This problem can be solved through several small solutions, including removing workstations that are not in use, removing excess skates, expanding storage areas, and installing more bins at the workstation for on-hand parts. We satisfied GE's request of changing the panel wiring one-piece flow to an assembly line style process. This resulted in a reduction in width and also allows us to reduce the footprint of staging for this area. With the new layout as developed through the spiral technique, we're able to centralize the key resources used by all departments within the wiring area. By positioning them in the middle of the wiring area, the workers have better access and shorter travel distances. We addressed the problem of underutilized and inappropriately used spaces within the department. We did so through eliminating unnecessary workstations, freeing up misused floor space, and introducing more hands-on storage to the workbenches so the workers can take fewer trips to the part storage area. As computed through the spiral method, the initial layout efficiency score was 51.9%, and the layout score was 81.5% for the final layout redesign. This is an increase of almost 50%. In our final recommendations, for the short term, we recommend introducing increased storage at the workbenches, because this is a simple and inexpensive change. We also recommend introducing the assembly line style process to the panel wiring one-piece flow line, because this is a change that will help reduce WIP and increase reliability. In the long run, we recommend that GE implements the layout as we developed above using the spiral technique, but first they may want to consider several factors including cost of implementation. We wish to give special thanks to GE management and employees as well as to our professor Dr. Norman. Thank you for your time.